Our task as a group was to calculate the yield of crops in a field such that the maximum yield was obtained. By choosing onions as our crop and by taking each onion as a perfect sphere, we thought that the areas would be easier to calculate, thus helping to form our equations. We derived an equation to create the shape of a logistics curve which represents population growth. We took this as a growth of biomass in an area. After inputting our figures from secondary research, we created a logistics curve with a sensible shape and limit which helps us to evaluate whether our research was valid and reliable. From this, we are able to calculate the yield from our crop values that we have substituted into our equations.
So to derive the equation for crop growth, we can use the factors R as rate of increase, P as mass of an onion, and K as carrying capacity. And we use the assumption that rate changes with population increase. So dP over dt is proportional to P, and you end up with this equation here, Rp times 1 minus P over K. So separating the variables, you get this, and then just times it by K to get rid of the fraction P over K. And then taking partial fractions of this to integrate it, you end up with A as K and B as minus K. And then that leads on to this log function, ln P minus ln K minus P equals RT plus C. Multiply it by minus 1 to rearrange it, and then use log rules to simplify it down. Take exponentials, and you end up with K minus P over P equals e to the minus RT plus C. Take the e to the c and replace it with the constant a, and you end up with this, ae to the minus rt. K minus p over p equals ae to the minus rt, and then p over p cancels to minus 1. So you just rearranging that, you get p equals k over ae to the minus t plus 1.
From our derived equation, we can produce the following equation by substituting a as e to the 6. This gives us the following graph, which ranges from 0 to 150 and shows an S shape with the increase of the mass. We can use this as our rate of change of mass, and it can then be integrated to find the mass at any point, which is given by this equation here. So M represents the mass of onion in grams, and T represents the time since it being planted in days. So we've assumed our seed mass is negligible. So when the time is equal to 0, the mass is going to be equal to 0. We can substitute this in to find our C as minus 1875 natural logarithm of e to the 6 plus 1. Combining these two results, we can get that our full equation for the mass at any point is 1875 times by the natural logarithm e to the 2 over 25 plus e to the 6 all over 1 plus e to the 6. Assuming our density of the onion is constant at the density of a full-grown large onion, it can be given as the mass of a large onion, which is 150 grams, divided by the volume of a large onion using the radius of 0.09525 meters. So therefore our volume at any point can be given by the equation here. Volume equals the mass over the density. So we times the equation for the mass by the reciprocal of the density to get our equation for our volume at any point in time. And as the area is directly related to the volume, we can get our area at any point in time given here. So the yield is given by the number of plants times by the total mass at that particular point in time. So this gives us the yield at any point in time during the growing process.
So here we have the masses for a large, medium and small onion with the radii next to them. Using the equation for mass from earlier, you can rearrange to find T, which is 44 days to the nearest day for a large onion. Using the area for equation from previous as well, you can work out how many onions can fit in a field of 1 hectare, The yield is approximately 52,627,200 grams per hectare for a single harvest. We have rounded this down so there is no overestimates. This will create a yield of 433 tonnes per hectare per year for a large onion. Following this through and work out similarly for a medium-sized onion, you get 40 days to the nearest harvest and an approximate yearly yield of 474 tonnes. Again, for a small onion, you get a 35-day harvest with a 550 tonnes per hectare per year for the yield.
For a single harvest, the three sizes of onions have an identical yield to three significant figures, but for a yearly harvest, small onions have a greater yield due to having a shorter growth time and hence having more harvests. Hope you've enjoyed this video. Thank you for watching.